The skin modifier is primarily used to create new geometry that wraps around an existing skeleton. This skeleton can operate in the form of simple edges and vertices, and the skin modifier will add new geometry, such as faces, that wrap around the structure of the initial model. To access the skin modifier, go to the Modifiers tab in the Properties panel. Select the Add Modifier button, go to Generate and select Skin. This will add the skin modifier to our existing object. To set up for a more complex example using the skin modifier, I'm just going to delete most of the geometry on our cube here. So I'm going to select these two vertices, invert my selection with Ctrl and I. Then I'm going to press X and delete the selected vertices. Next, I'll go into Object Mode, go to the Object menu, Set Origin, and I'll set the geometry to the object origin. Next, I'm going to go into Front Orthographic View. I'm going to move into Edit Mode, and I'm going to start extruding vertices on one side of my model. So I'll extrude some vertices here. This is going to help create one of the legs. And over here, let's create a shoulder, upper arm, lower arm, and a hand. Then I'm just going to create a few more vertices for the head and neck. Next, I'm going to combine skin modifier with the mirror modifier. So we're going to use the mirror modifier first. We're going to enable clipping and merging, and we're going to make sure that the geometry has fully merged down the center, just in case any duplicate geometry is created. And we can either apply this, or we can just leave it as is and then work with the skin modifier after the fact. But for now, I think I'm actually going to apply, because it's just a simple mesh. Then we're going to add the skin modifier. Here we've got a very basic representation of a humanoid-like character that we can begin to work with. The first property that we'll look at is branch smoothing. Now I'm just going to hide the effect of the skin modifier, and what branch smoothing does is it locates any areas of your skeletal mesh, so the wireframe that you used to create the actual object, and it locates the vertices that have 3 or more edges attached to them. So this vertex right here has 3 edges. This vertex up here has 4 edges. So when we use the branch smoothing option, it's going to relax the geometry around those areas. By default, it's set to 0, but as I click and drag to improve the branch smoothing, you can see how in these areas, the geometry starts to tighten around those points. Then we have symmetry, so we can symmetrize geometry on the X, Y, and Z axes. One thing to note here is that this is not the same as flipping the geometry over from one axis to another, like we would see with the mirror modifier. That's why I use the mirror modifier first to generate the skeletal version of the mesh. I did not rely on the skin modifier to do this because that's not what symmetry is doing when it comes to the skin modifier. Instead, what these checkboxes are designed to do is they are designed to ensure that the topology that is generated from the skin modifier looks the same on both sides of an axis. Now this is a relatively simple construct, but let's see what happens if I untick the box for X symmetry. You'll probably notice that the geometry has shifted around the inner thigh area. If we turn it back on, you can see that it better mimics over from the right side to the left. But manipulating this value, we can clearly see that some of the generated geometry is not lined up correctly if we're not using this symmetry value. A key hint here is to use the line of symmetry that you used for the mirror modifier. So if you used the x-axis for the mirror modifier, you would use the x-axis for the symmetry property of the skin modifier to get the best results. Below our selection of symmetry, we have a simple checkbox to allow smooth shading on our generated geometry. As you may expect, all this does is convert the shading method on the created geometry from flat shading, where we can see all of the individual faces, to smooth shading, which is a more organic look for the model in general. Because this is a modifier that generates new geometry, that geometry can be further adjusted using other modifiers. One such example is Subdivision surface. Typically, when we use the skin modifier, it's not going to generate an awful lot of geometry to use. It all depends on the number of points that you create from the skeleton. But even despite this, each point effectively creates a cube, and this is added on top of the skeletal mesh. To increase the amount of geometry and to further improve our shape, we can add modifiers like Subdivision surface. This will significantly increase the amount of geometry created from the skin modifier. Again, we can manipulate the viewport levels and render levels along with more advanced settings if you require. But as you can see, the result is a more cleaner approach, especially when combined with smooth shading. But the order of the modifiers is just as important. So as a reminder, you can see here that we have the original mesh and we have all of these individual points. Now if we were to take our Subdivision surface modifier and place it above the skin modifier, nothing's going to change in edit mode per se. But if we were to go back into object mode and then view our skin modifier again, the result changes quite drastically. And the reason why is because if we place Subdivision surface before the skin modifier, then these vertices are what will be subdivided. And then the skin modifier is going to take those vertices and create the new mesh on top of them. The result may be blocks or cubes that are combined together and overlap each other, which creates distortion, artifacts, and generally poor topology. Therefore, the recommendation is to place Subdivision surface below the skin modifier so that you can create the mesh exactly how you want using the skeleton, and then increase the geometry with Subdivision surface. The skin modifier is a rare case in the modifier stack of a modifier that allows you to access different parameters depending on the mode that you are in. So right now I'm in object mode and I have my skin modifier. I've taken off Subdivision surface for the moment, but you can see here we have a single option, which is to create an armature. Now this option is only available in object mode, but how do we access the other parameters here? Because they're currently grayed out, we can't actually use them. Well, all I'd need to do is go into edit mode. In this mode, I can no longer create the armature, but the loose options and the root option, as well as the equalize radii option, these all become available. So if you're new to the skin modifier and you're wondering why some of these options are grayed out, just change the mode that you are currently using. So the first option here is to create a new armature, which is only available in object mode. To best display this, I'm actually going to toggle the visibility of the generated geometry. So at the moment we can only see the skeletal mesh. Now I'm going to click Create Armature. You should see that the mesh looks slightly different, and that's because a new armature has been added at the position or location of each individual edge on our original mesh. So where we had edges before, we now have bones on top of those meshes, and those bones actually line up perfectly with each edge. You can see in the outliner that we have created a new armature object, and it automatically becomes selected instead of the original model. You can see now that as I select the original model, which is the cube, we can't actually see anything that's selected on the object, and the reason why is because the bones now overlap the individual edges. If I left click on the model, it's actually going to select the armature in this case. So if I want to access my modifier stack again, I would need to select the cube ideally in the outliner panel, and this gives me access to my skin modifier as well as the armature modifier, which is automatically added underneath the skin one. The third thing that the skin modifier will do when we create an armature is it will automatically add weights to the individually created bones of the armature. So if I select the armature again, I can go into pose mode and select any of these individual bones. You see they should highlight blue. There's an additional one that's located here, and this is a control bone, so to speak, and it effectively allows us to lies underneath. But if we select another one of these bones and press the G key, you can actually see that we're able to move it around in the 3D viewport as if it had a joint here. So it's actually operating more like a skeleton now. We have the hand, we have the lower arm, we have the upper arm, we have the shoulder, the top of the head, etc. So we can now manipulate this skeleton almost as if it was a character mesh. And this is actually one of the main reasons why I would personally love to use the skin modifier for creating objects that I can animate, because it's one of the easiest ways in which we can generate a fully functioning armature that we can actually animate further down the line. So again, if I was to select my cube object and bring back the skin of the mesh, we can now see underneath the armature, and we can select that armature, go into pose mode, and begin to move about the individual bones so that we can create movements or animations that are similar to a character model. When working with the skin modifier, there is an additional tool that at first is actually quite hidden because it's not located within the skin modifier, and this is known as the Skin Resize tool. Skin Resize allows us to select a vertex and then either expand or contract the geometry created from that vertex using the skin modifier. So I'm going to start by hiding the armature, and also I'm going to enable wireframe mode so that we can see the mesh underneath. Currently I'm in edit mode, and you can see the skeleton of the mesh used to create the geometry, and on the outside of those vertices you can see the generated geometry itself. Now what I can do here is I can select a vertex, I can go to the mesh menu, go to transform, and come to Skin Resize, or I can use the hotkey, which is Control and A. So this is going to scale selected vertices in terms of their skin radii, which in layman's terms is effectively, if I use Control A, the size of the geometry that is generated from that point. So here I've got a vertex selected, I use Control and A, and I can either scale it out or scale it in using the Control A hotkey. I can do this with any vertex. So if I wanted to start generating something that looked a little bit more like an arm, I can take this vertex here, scale it in, so that we have something that looks like a wrist. Maybe I scale this vertex in as well. And the general shape of this part of the model starts to look a little bit more reminiscent to the arm of a human character. Another thing to keep in mind when using skin resize is that every vertex is independent when using this tool. So if we select multiple vertices and use Ctrl A, they won't be affected by each other. They will simply affect the geometry that they themselves generate. So here I've got two vertices on either side of the arm. I can use Ctrl A and I can bring both of them in at the same time. I can repeat the process with these two vertices, hit Ctrl A and scale them in. So I can create the shape of both arms at the same time just by selecting two vertices. When using the skin modifier, there are three terms that you should learn. These are loose, root, and radii. The first one is the root. Now, when we refer to the root with the skin modifier, this is going to be a specific vertex from which the geometry is going to begin to be formed. So even with the skin modifier or any modifier, there's always going to be a starting point, but it's particularly important for the skin modifier to have a defined starting point on the model so that it can be more easily generated and so that the armature can fit better to the model. You can identify which vertex is marked as the root one because it's going to be surrounded by a dotted red circle. So this vertex right here, this is the root vertex for our object. It was automatically assigned because of its location. However, we can change the root vertex by just selecting another vertex on the skeleton and selecting Mark Root. This does two things. First of all, it will mark the new vertex as the root. Second of all, you will notice that it's actually altered the geometry somewhat around the head and neck area. Watch if I change it back to the original location. Keep an eye on the neck area in particular. I'm going to mark as root, and the topology shifts again. So where you choose to mark the root vertex is going to be very important in terms of how your geometry will start to form. Another key thing to consider is that when choosing the vertex that's going to act as the root of your geometry, this vertex should be positioned along a line of symmetry. In this case, our model is symmetrical effectively along the x-axis. So this vertex, which is marked as the root, ideally should have a local coordinate value of 0 on the x-axis. Here I've got a slightly different example in which I'm going to use to just demonstrate the radii. Now the radii, or radii, I'm not entirely sure how to pronounce it myself, is going to equalize the amount in which a vertex's generated geometry scales on the x and y axes. Now when we use Ctrl and A to scale up or scale down the generated geometry, we are in fact working in two axes and not three. These are the x and y axes. But when we do use Ctrl and A, we're scaling on both of these axes by the same amount. Now, if I was to press X while active, it would only scale on the x-axis for the geometry's radii. If I was to press Y, it would only scale on the y-axis. Now, when we do this, we can create different shapes, and this is actually a great way of creating shapes for things like fingers or appendages. If you take a look in the side panel, which you can open up by using the N key, you'll have these radius X and radius Y values. The equalize radii option applies for when you want to normalize these two values so that they become the same. Because these are different, we can now press Equalize Radii and it's going to find a midpoint between these two values and set them both accordingly. So I'm going to left click for Equalize Radii and it's going to set the X and Y values to 0.339 in this example. And you can see it's also shifted our geometry so that now in both directions, on the X-axis and Y-axis, this geometry is once again being scaled uniformly. So again, just to clarify, when we refer to radii, we are referring to the thickness of the geometry that is generated specifically by the skin modifier. And we can manipulate it on the X and Y axes independently if we need to, and we can equalize these values by clicking on this option in the skin modifier itself. When we talk about creating loose geometry, we are in fact referring to branch vertices. So you might read this and think, okay, this is going to do something to the vertices at the end of my model. But that's not the case. Actually, this is going to be used for when you want to manipulate a branch vertex, which is simply any vertex that has 3 or more edges connected to it. So with these branch vertices, the geometry is being produced in different directions. What that means is that Blender, when it uses the skin modifier, it's going to automatically add additional edge loops where required around these branch vertices that wouldn't normally be created elsewhere. These additional edge loops are going to maintain a reasonable shape around that branch vertex. However, what if you didn't want Blender to do this? Well, you would simply select the vertex and mark it as a loose vertex. As soon as I do that in this example, you can see the geometry has shifted. I can clear the marking of the vertex by choosing Clear Loose. That reverts it back to what it was before. If we take this vertex as another example, we can mark Loose, and it seems to have an even more apparent effect. So in this example, rather than extruding the geometry in 2 different directions, it's extruding that geometry in all directions around the branch vertex. This means that it's going to cover a greater surface area. We can still take those end vertices and manipulate their position to manipulate the generated geometry. But now the loop cuts are not being added, or the edge loops are not being added around the branch vertex. So that geometry is of course going to space out depending on the position of the end vertices. This will work with any geometry or any vertex that has more than 2 edges associated to it. This edge right here, or this vertex I should say, has 4 edges. Therefore, if we mark Loose, it's going to have an even more profound effect on the model, and this may actually require a little bit of editing using the radius values, Control A, or just repositioning the geometry so that we don't get any overlapping, which may be the case here. However, if we were to pick an end vertex and mark it as loose, nothing would happen. If we were to extrude this one out, select this vertex again, which now has 2 edges associated to it, and again mark loose, nothing happens, because the geometry that is generated here is the normal geometry of the skin modifier. No additional loops need to be created. We just generate the geometry required to go from one vertex to the next. And that's also the case with the end vertices. No more geometry needs to be generated past this point, therefore no change is going to be made at that point of the model. The final option in the skin modifier is the ability to add skin data. This is grayed out regardless of whether you are in object mode or edit mode. And the reason why this is the case is that by default, skin data is added as soon as you add the skin modifier. So in this example, I'm just going to demonstrate how you can manually remove the skin data for your model, and then how you can add the skin data back using this option. So also keep in mind at the moment, the current shape of this object. I'm just going to make a few changes to the model, just so we've got something that looks very different. And then we're going to select everything with the A key. Keep in mind we're in edit mode. We're going to go to the data tab in the properties panel, come down to where it says geometry data, open it up and select the option that reads clear skin data. When you left click, all of the generated geometry should disappear. Then return to the modifier, and here we're going to add skin data. So left click, and it adds a new skin layer for the model. And what's perhaps most important about this here is that all of the geometry is uniformly added. So all of the changes that we made to the individual vertices in terms of the X and Y radius, those have been replaced because we deleted that information when we removed that skin layer. And when we added the new one, it effectively reset the skin modifier back to the default settings in terms of the thickness of our individual vertices. So that wraps up the skin modifier and all of its core parameters. I hope you now have an understanding as to how you can use the skin modifier to very quickly create more complex looking models than you would using traditional modeling methods. For now, that's it from me, but if you want to learn more about the different tools and modifiers in Blender, then don't forget to like, subscribe, and hit the notifications bell icon for more updates and future videos. For now, bye bye.